Hello everyone, hope you all are doing very well. Very recently, I was introduced to this SaaS platform named GigaSheet, where you could import your CSV, Excel, any kind of data set, and you can process it. You can perform various analytical operations on it, and you can pretty much do majority of the things what you could have done on the Google Sheet as well as the Microsoft Excel, but all in the SaaS environment. One of the biggest reason GigaSheet is available because the online version of Excel as well as the sheets may not be able to perform operations when you have massive amount of data in millions or the billions of the rows, where the GigaSheet creators are claiming that their GigaSheet can properly function, process analytical operations on the given data set without even having a problem to process very large data. So I found it's a great opportunity for anyone to see that all the operations which you are going to perform in the Pandas data frame in whatever runtime environment you have, and see those applications or those analytical operations done in the GUI or the GUI based format of GigaSheet. So in this video, you are going to learn side-by-side comparison of GigaSheet and the Pandas data frame operations in code and in UI. So you will learn that everything what the GigaSheet is providing as an analytical interface to the sheet or to the data set based on rows and columns, you can take advantage of your knowledge, vice versa. If you want to use the free version of GigaSheet, you can use free or paid version and apply all those operations on your data frame, as well as if you do not want, then you can apply everything as it is in the Pandas data frame by loading your own data set and apply various operations. So in this video, we start by ourselves uploading the main delayed flight data set, which has about 1.9 million rows, and then process it through various operations available in this GigaSheet GUI interface, while side by side we learn how we upload the same file in the Pandas environment and apply various operations as we move ourselves side by side between GigaSheet and the Pandas, and slowly we learn the majority of the informations available within the GigaSheet interface as well as in the Pandas environment. We cover various operations what anyone would want to perform in their data related to analytics as well as the insight available in their given source data, which includes grouping, creating new columns, merging information from other data sets, such as here we are importing the airport codes, and then we update our data set by adding the airport name and the airport city based on the origin as well as the destination values in the source data set, similar to the merge operation we perform in Pandas. And finally, we complete this tutorial by updating the data in the GigaSheet and the Pandas Jupyter Notebook we export at the GitHub. So this Jupyter Notebook becomes the worksheet which anybody can follow at the end of this video. So now let's take a very quick end-to-end demo while importing and processing the data in a GigaSheet, while side by side looking into how you are going to follow the same steps in the Pandas. So first thing, if you would want to upload or process a CSV file in Pandas, you can use whatever environment you have. Because I am running this whole demo in the Google Colab, so I will be uploading the CSV file directly from my local file system to Google Colab. I can select the file. So the file name is delayedflight.csv.zip. So the data set which we are uploading at the Google Colab is actually downloaded from this Kaggle dataset, delayed flight. It has about 1.9 million rows in 30 columns, about 240 meg data. So while this file is being uploaded from my local file system to the Google Colab environment, I can do exact same thing coming into the GigaSheet, select a new file upload option and drop the same file here. So delayed flight.csv is also being uploaded to the GigaSheet while the same file is also being uploaded to the Google Colab environment. So these two files are being uploaded from my local file system to GigaSheet as well as the Pandas. And then we can start our processing when both files are available, when the same file is available on the both environment. To complete this demo, you must have your account with Kaggle, and once you have account, then you can select this particular file and you can download by using this option. As you could see, that file has been uploaded and now it's been processing. So in the processing stage, the GigaSheet backend is actually trying to understand more about the data set. A metadata is being generated, which will be displayed within the library. So now you can get an idea that it has about 1.9 million rows, 31 columns, and that is the part of library. It means once you select the file, it will open that file into a new workspace, and we can see about 140 rows for this sheet is available. Here are all the columns related to this particular CSV file. We can take a look here, and almost 48% of this file, about 250 meg, is being uploaded. So while this file is being uploaded here, I will just give you a quick run about here. Here is the file if you would want to save as or export this particular file, because whatever you are going to perform here, you have ability to export some of the cleaning functions related to your data set. Here is the columns if you would want to filter some of the column and you do not want to see. So here are the taxi in and taxi out column, but if you decide you do not want to see, those columns will not be visible here. If you would say that, oh, based on 1.9 million rows, how many flights are cancelled or not? So you can come to the cancel and you could say I would want to filter this data where cancel is equals to, you could say yes, cancellation was done. You can apply, processing has happened, and as you could see here that the cancelled about 633 flights were cancelled. If you come back here, you would say that rather than cancelled, I would want to know how many non-cancelled, and you apply this, you will find that minus 630 we have seen earlier. They were, so these are the flight not cancelled. So it means the airline delay did not really cause the cancellation. So the filtration was the very first option you have seen. If you would want to sort this data in the cancellation versus non-cancellation, you can first go ahead and remove all the filters. So we do not have any filters built into. Now you can say, okay, let's sort. Now you see that all the cancelled flights are first, and then at the bottom there will be non-cancelled flight. So you could sort this information. So as you could see here, when we click and see this change data type option, you could see that actually currently this column is set to number. However, if you would want to change this number to something different, if you'd want to convert to text, you could do it. There is another built-in column called the IP address as well as the date. But we do not want to change anything here, so we will keep it as it is. Let's come back here and see our file is 98% done. As you could see here that our file is uploaded. Once file is uploaded, we can actually look into where this file is, so ls.la, and you could see that we do have access to this file in the Google Colab environment. So now once this file is uploaded from our local file system to Google Colab, now we need to use this file, so we need to read it. So we could say df is equal to pandas.read CSV, and that's where you need to provide your file name. So that is your file, and this file is about 250 megs. So it's going to take some time from this file to be read from the local file system in Google Colab and loaded into the Pandas environment. So now df is available as a data frame object. So it's a Python object, and then it's a Pandas data frame type. So you can say df, and it really gives you a sample of first 5 and bottom 5 rows. If you would want to know that how many rows and columns are there, you could say df dot shape, and it's going to tell you that it has 1.93 million rows and 30 columns. Similar to here, like it's telling you that total there are that many rows and sampling is there. So side by side, if you would want to look the GigaSheet and the Pandas, you can actually say that, oh, I really need to see the df dot head, and it will give you the first 10 row. If you would say that I need to see the bottom, you could say df dot tail. It gives you the bottom 10 row. If you are interested to say actually I need 100 rows, it will give you the top 100 rows here, df dot head, but it's actually concatenated here. But if you say I need about 20 rows, so as you could see here that there is a visibility for certain rows, but as soon as you will cross the visibility range, the number of rows will be truncated. Similar to here, you can get the tail of 20 rows, but as soon as you are going to say I need, for example, 50 rows, you will see the 50 is also visible, but when you say 100, the truncation starts. So you can get an idea that how many rows you could see. So from bottom and from top. However, if you would want to sample this data randomly, then you can actually say that data frame object dot sample, and you could say that give me the 10 samples. So randomly rows will be selected out of 1.93 million. You could say, can I get the sample of 100 rows? And randomly rows will be selected. So this is the row index. That's where you can get an idea, but it's truncated. So you can use the 50 and it's going to show you. So for example, if you are trying to create a sample and you would want to use it, you can actually take this data frame and you can say I would want to save this, okay, and then that's where you can provide your path, and that random 50 rows will be saved for you, which you could send it to somebody. So for example, if you say I need to save 50 of these rows or maybe 100 of these rows, then you can write 100 here and then you can say 100 rows dot CSV, and you are going to run. Now this file is actually saved into the 100 rows, and then you can say ls-la, and these 100 rows are available here, which is about 1.3K file. So you can get an idea that when you are sampling or using head, tail or sample, you can export the data. That's the reason you would want to sample or just want to take a look. Let's come back here again. So we have seen the side by side, the sampling, and then looking into the total number of columns and what the type. So Pandas gives you little more explorability. So you can say the given data frame dot columns, and it shows you the total number of columns. So after you get column, it just shows that these are the columns you have, but you would want to know what these column types are. Here you are looking into the columns and you can say what this type is, and it really tells you that this is the number. Or if you go look into the origin, which is actually telling that this is the text type. Pandas goes a little more deeper, and you could say that df dot d types. So here you could see that integer, float, object, which is most of the string. However, if you would want to go a little more deeper, you want to convert this unique carrier to a categorical, then you can apply the categorical. And then categorical column is treated as a numeric inside the data frame. However, the visible perspective really look like is exact the way your values will be. If you would want to the number of rows depending on your field. So for example, if you would want to know that depending on what the destinations are, how many unique values are in the destination. So here you see that at the very bottom, there are actions. Actions really tell that what a particular analysis you would want to do on the given column value. So you say how many rows are there. So we already know that rows will be same as this. Then you would say that how many empty values are there. There are no empty values. You would want to know how many filled, 100% filled value. Then you would want to know that how many unique value. So out of that, it shows that there are 304 destinations are covered around 1.93 million airline records. You would want to know that percent filled, percent empty, and percent unique. So that's, percent is calculated based on these three values. So this is your destination column, which is the text. However, if you take the numeric column, so for example, if we are taking the numeric column, which is the departure delay here, and departure delay or arrival delay. So we can actually select the departure delay column, which actually here you can see that this is a numeric column. You can go all the way down. Now you have little more column specific operations available. You can still get the row count and the empty and unique and the field, but in between you can see there is a sum, average, median, min, max. These capabilities are available. You can sum it out. All the values will be summed here. You would want to get the average. You can get the average here. So you can get an idea that depending on whatever field you will select, you have ability to perform various column specific operations within the column also. You say how many unique values are there? 0.05. It means if you take the how many unique values are as number, you will see about 1000 unique values. But it doesn't really matter because this is numeric column. If we look into the origin, which is character, that's where the uniqueness is going to be. It's going to say that are 303 origins and about 304 destinations. So now if we would want to come back and perform these similar operations in the pandas, this is how we are going to do. So for example, we were in the DF here, and DF, then we are interested into our column we were working on, the cancelled or non-cancelled. So you will say I'm interested into cancelled. So this is the DF cancelled, and if you do that way, it is going to perform the error, because if you would want to get the subset of your column, you need to put this thing into the another array. And now we get an error because the cancelled here is a uppercase. So you have to make sure that your column names are correctly referenced. So if we make this thing uppercase cancelled, now you run. So this is the subset of the data frame. It's still in memory. It hasn't performed any operation to existing data frame permanently, but it's subset it. If we would want to save this thing in something, so you could say df cancelled equals to this result will be stored into this new data frame if you would want that. Now you see that for df cancelled, how many values are cancelled and how many values are non-cancelled. So you can say n unique, and when you run this code, it actually gives you the n unique values 0 and 1. And now if you look into here, you will see that there are two kinds of unique. So it means that the values uniqueness is 2, similar to here. So when we were performing the uniqueness here in the cancelled, how many uniques are there? As you could see here, the value is 2, which is similar to here. Same thing, you could really apply the same logic if you would want to know that how many origins and destinations are. You could say, give me the total origins. Is going to give you 303. If you are going to look for the destinations, you just need to provide the proper column name, which is the dest here, and it's really going to give you destination column. Now if you are interested to find, okay, these values, give me the unique values out from this data set. So now we need to get the unique values out. For example, in the cancelled column, the values are 0 and 1. So one thing you need to recognize is that we are saying n unique. It means number of unique. So if you take this line and you can say what are the unique value here. So if you say unique and for the given column, and if you will run it, you will find that if you are creating an operation like that on a data frame, it is giving you an error. Now there is another way you can access the column. The trick is that you can actually directly call the column name on the given data frame. So here you see that I'm calling df.cancelled, and if I right click here, that is actually giving us the same value which we were getting when we just call the df cancelled. So if I come here, create a new row, you are going to see the result here, which is as a data frame. So if you say what is the type of this value is a data frame. However, if you are looking into here, the result is as the list. So that's how you can get the values coming out of the column. Now you can take this and you could say that give me the unique. And if you say give me the unique, and that is going to give you the values are 0 and 1. Similar to that, if you say what are the origin, the origin is a column name and it gives you these are the 303 origin. If you would want to run same thing on the destination, and here are the uniques into the destination. So you can get an idea, these are the 304 and these are the 303. So if you would want to get the unique, which was not applicable to this way, but there is another way you could go, because you rather than referencing to the column set, you can actually use a single column. Hold on. What you do, you just run as a single. So here you say I'm referencing to the df cancelled and give me the unique. And now you see the same value which is related to cancelled unique is available for you, but you cannot use the same method which we have used earlier to get the any unique. So here we have done unique, and we have also looked into the total number of empty, total number of filled means missing, as well as the filled. So let's take a look here and how we can recognize those values in our given data frame, which is generated from the data set. Let's select a numeric column. So for example, we had departure delay and arrival delay. So we can select same way in our pandas. So df of, let's take a column. So we are interested into the departure delay. So let's use the departure delay. So that's the column. Now if you would want to perform various operations on that, so here you could say give me the sum of all values. You could say give me the min of value, give me the max of these values. If you are interested look into, you could say that I really need the not max, I'm looking for the mean value. If you are interested into the median, this is the median value. So mean, median you are getting. What about the looking into the average? Average is not available. Let's try to see if AVG. So we need to use the mean as the average here. And how you can get, because you need sum, so you could take this sum, df of sum, okay, and then you can say that what is the length of the df, and if you divide it, this is the 43, which is exactly the value to the mean. So this is how you can actually come up with your own average. So you could say that df of, here you have decided that whatever the sum is, I would take the length of data frame and I will divide it, and that is going to give us the average, creating your own average method, which is exactly the mean here. So we have seen for the numeric column how you will be able to perform these mathematical operations. Now let's try to look into the empty and filled. So for df, you can actually say that df, which is your data frame, is na. So is na method is not available, versus when you say is na, so it will say yes. So similar to that, you could actually say df dot is null, and it tells you that how many values are null in your data set. Now this result may not be really good to understand if you have millions of rows with really tens or 20s and 30s or hundreds of columns. So you can actually apply the count on it. So you could say that whatever this value is, can I get the count? And it's telling that out of these values, if there is any, and here you could see that there is no missing values here, because this is really converting all the totals. But count is not going to help. So what you could do, you can take the same here and then you can say, can I sum it? And if you are trying to sum these values, now you are getting little more information. It really tells that for the is NA, these values are 0, but in arrival time, there are NA value. Similar to that, let's look into the sum of is null. So taxi in, these are the values. So one thing we can validate from here, that if you look into the taxi in, the 7110 values are coming as a null or NA. So based on our analysis using pandas, we could see that there are definitely some of the values which are either not available or the null. Versus here, it is very much possible that when the data set was loaded, all the NA or the missings has been updated with the corresponding value depending on some of the logic. One more thing we can cover here is that when we have our data frame, we can run command like df.describe, and if we just run describe here, you will see that some of this information related to every column is available for you in little more details as ND frame. But if you select the df.describe here, and you are getting information related to total count, mean, standard deviation, minimum at 20, 50 and 75% quintile, as well as the max, but that is only available for the numeric columns, versus df.describe is actually giving just a standard snapshot of other all available column. Similar to that, you can also apply the df.info, and that is giving you the details related to the column and their type and the total memory uses in. So this particular data frame is consuming 443 meg memory in the RAM and within the Python runtime, which is loading this Pandas library. Comparative to that, in the GigaSheet, you really have to come and you need to look into a specific column section and see what is your interest specific to describe as well as the info related commands with Pandas. We have already saw that how you could sort these values just by selecting a sort operation, ascending or descending specific to given column in the Pandas. So you have data frame dot sort, and if you give few seconds, it gives you the method, so sort values, and you can provide which particular column you are interested into. So you could say I'm interested into the cancelled, and the same data frame sorted is built into, where if you look into the cancelled, this is the started from 0 and then once is a ascending order. If you would want to change its order, you can come here and wait for few seconds and it will give you the option. So ascending is bool, true by default. So you could say ascending is false, and now the cancelled order has been changed. Similar to that, if you are trying to use the column which is character or the string such as origin and destination, so you could actually similar to that origin, and because as you see here dot dot dot, so origin is really missing because it is in between column while we are looking into data. So it's, if you are interested to look into, you need to subset this column into some of the total number of fields you are interested into. So for example, you could say like this way, you are interested in origin. If you add more, for example, destination, now you are getting the origin and destination. So the origin is sorted based on ascending as a false. If you change to true, which is default. So I will keep this as a row here and make sure that we do not use this that way. So you can get an idea that why we have to filter some of the columns so that we could see the results. One thing I wanted to show you, that while we were sorting this value here on cancelled, as you could see here that in the cancellation, some of the values are visible as a nan here. It means that the carrier delay or the weather delay, definitely there are lots of nan values which we have seen earlier. So here you could see that about 689,000 values are actually the nan here is not available, or they are null, which are visible clearly in this option. So if we will go a little more deeper to analyze it, we could actually say we are interested into the carrier delay. Let's sort it. All the values start from 0, and all in the bottom, all these values going to be the NaN values. So you can get an idea. There is a lot you can do and spend hours just to analyze these values, but it gives you side-by-side comparison between the GigaSheet as well as the Pandas. One operation you might be interested in creating the column with a new name. So for example, if you say that, oh, if I'm interested into changing the flight diverted, so if this is the flight was diverted or not, you can rename the column here, and you can say I would like to call it flight diverted, and you can save. Now your diverted column has become the flight diverted, and that name has been updated here. Similar to that, if you would want to change that particular name up to here, your df dot columns, you will see that you still have the column called diverted. So if you would want to change this name, you could actually just rename. You could say df dot rename, and then you can say that which column you want to convert into. So here you could say that df dot rename, and you want to do columns equals the source column and your new name column. So you could say that I want a diverted, and I want to call it flight diverted, and let's run it. What happens, I will show you. So if you look into here, you have converted, and if you look into your column name diverted, which is not listed here, let's try to say give me the list of column names. So that's the df dot columns, and if you see here, the diverted has been updated to flight diverted here. So if this time, if you say df dot columns, you see here there is a change, because in this operation the data frame column name has been changed, but here in the original data frame is still there. It means a copy of data frame has been created with the different name for that particular operations only, but original data frame is still sitting there as the same name. So you have to go ahead and you need to make sure that in the columns after, you make sure that you say change it to in place. So in place equals true. Once you said in place equals true, now this is not going to work. So I will make sure that I will create a new row here. So this was our result, and this result was not applied. So now I will create a new action here in place, and then remove these columns from here. So now the df update, if we try to look into the columns, now you see that after this particular in place equals true, now the df has been permanently updated with this flight diverted column name. So if we look into the df dot samples, and here we could see the flight diverted column is here. So you can get an idea how you could replace your column names similar to here. However, if you look into this carrier, the flight diverted, you need to make sure that if you would want to save or you want to export it, you can actually change the new data frame depending on whatever your need is. Previously, when we were filtering, we were able to filter very quickly by just giving the value. So select the column, select the filter, and then we can say whatever options we are interested into. Here are all the values available. So you could say the taxi in equals, or if you say greater than or equal to, does not equal to, or there are other options greater than. So if you say the taxi in time is above 100, and if you apply, that is giving you the result related with your taxi in. So taxi in, these are the row count 7,000. Let me just make sure that row count is calculated again. So 259 records are actually here, which are the taxi in time is over 100 minutes. If you would want to filter same result in the pandas, we can come back here. We could say df, then select the df dot taxi. We need to make sure the column name is correct. So taxi in, uppercase in, taxi in, and if we just select this way, you will get the data frame filtered on taxi in, but there are some errors. So you could say I'm interested into the taxi in is greater than 0. And now you will get, because when you are trying to pass a column like that, the data frame is expecting an operation. So now it says that, okay, 259 rows are greater than 100, which is exactly the same results what we have seen here. And if you would want to take then extract it into a new data frame, just equals to, you can just say df new, and it will store all this result into a new data frame, and then you can process it. So in the next step, we want to create a new column where we would say that what if all the values where the taxi in time is greater than 100 should be true, otherwise false. So it means that in the existing data frame, we need to create a new column. So it's gonna be taxi in time is greater than 100. That's the column name. And we would want to create something like this. So how you are going to perform the operation, something like that. So there is one thing what you could do is that you could use the NumPy library. So you can say import NumPy as np, and here you could say np.where, and you can provide the condition. So this is your condition. So where df, so this is your condition. So where df.taxin is greater than 100. If this is 100, then true, otherwise it's a false, and that will be your condition, and the result of this condition will be stored as a true and false in this column gt100. Let's run it. Now if you look into the df dot shape 31 columns, let's look into the df dot columns, you will see that this new column has been added. And if you take the df dot sample of 10, the last column, you will see that there is a all false value. If we say, just an example, how many values are the delay is over 10, then 244,000 values are that. In that scenario, we could actually apply this, and then we will be able to get a lot more true and false. But essentially you get an idea how you can create a new column based on true and false value. So the version I am using right now, maybe in upgraded or paid version or something, you have ability to add a new column, which I could not find. Insert just has bunch of methods such as providing some calculations. So for example, if you would want to create a new column based on two valued sum. So for example, if you will say what is your arrival delay and what is your departure delay, and you want to create a new column. So for example, let's come to here, insert calculations. You could say I am interested into the arrival delay plus the departure delay, and then apply. So here is created a new column called arrival delay plus departure delay, and that new column has been added into the list. It's called the arrival plus departure delay. So those insert methods are built in. If you would want to do exact same thing, arrival delay plus departure delay, that's very easily you could do here. You could say df new, let's see what is the, so arrival delay plus dep delay equals to df of departure delay. That's it, and the values of each sum will be added into here. Now if you look into the df, a new column will be added, airline plus departure delay, and a new column added, which is exactly the same what we have done here in the GigaSheet. So in the next step, we are looking into the how to perform the GroupBy operations both in Pandas as well as in GigaSheet. So let's look into the df.GroupBy. So GroupBy is the method available in the Pandas, and we can select a particular column. So let me select a particular column, and we will be looking into the GroupBy based on the values which we have earlier processed, such as the destination as well as the origin. So GroupBy origin. Okay. So now we have a data frame GroupBy object is created based on that. It means that we could actually perform certain operations on that. So now operations can be, you can say I need a count. It will tell you that df group by count. So this is the new data set has been created, which actually tells that for a given origin, what is the count. But if you look into, the count is exactly the same for every column. You really do not see any change. So if you would want to apply the group by with a particular other column, so you could say the df.groupby and your column is origin, but let's see the destination. So you could say group by, here is your origin. Then you are trying to say what is the destination. And then if you say I would want to perform the count, so same 303 row, but comparative to the origin was the group by, and then we only selected the destination column, and thus you have received the count for the given origin. Means that for ABE origin there are 949 records. For ABQ Albuquerque 10,674. If you'd want to run the group by with multiple columns, then you can add multiple columns here against this column. Now if you take the same operation and you would say what is the max, what is the min, you are getting the idea about that what the max value is, where the min value is. So mathematical operations can be applied to the group by. Similar to that, now we could come back and say we will need to apply the similar group by here in the GigaSheet. So here is the group by. You could say I need to create the group by on the column is the origin. This is our origin column, group by. And as you see in the background, so group by updated in the background. So 303 row being selected based on origin. If you are interested into the column here, you could say the destination. So depending on origin to destination, you can add a new column as you proceed. We do not need. So these are the two columns. So that's our group by result right now. You see that these are the group by, and here the operations is really being used as a sum. If you want to change this group by to a different, you could say I need a min, I need the max. So you can get an idea that the way you are going to perform the group by operation in GigaSheet is here. And if you will take this and you will say, okay, I would like to save as this as a group by origin destination. Let's save it. Let's come back to library. So what we have done is that we have saved the copy of this which support the origin and the destination based on this mathematical sum. So now you can get an idea that how you could group by multiple columns, and then you can apply the certain mathematical aggregation on top of your group by. So now in this next exercise, which will be our last exercise, where we are going to add the airline source and destination location based on its code. So as you see here that we have df, where we have df origin as well as the destination. So let me make sure origin, df of origin, and we also have the destination. These are the code. So we need to add the origin city name and destination city name like a full. So in that case, we need to refer the new data sheet where we have access to the origin code and the real city name, as well as the destination code and the destination city name. So we need to integrate that from an external file and add that new column here. So we can look into a particular file which is available on GitHub. So here in the GitHub, where you could find the international code for every airport as well as the full city name, which country it exists and what's the GPS coordinate. So let's take this URL and read this. So we will call it airport codes is equal to pandas dot read CSV, and that will be our path. That's the data set we have. Here is the local code, here is the IATA code. And because our initial data set is all about United States, so we could say that airport codes is equal to, just select only the US. So we could say airport codes equals to airport code where we just need to filter the airport codes of ISO country is equal to US. Now if you look into our airport codes, it has initially 55,000 rows. Now it only has a 22,000 rows because we have only selected everything in the United States. Now we can look into if there are is NA dot count, look into is null count. We can give a quick test in the airport codes and see that airport code, if any of the code which really matches. So for example, our origin is IAD and we can say airport codes, and we are looking into the field is IATA code. So here we could say that IATA code, so airport codes of airport code, IATA code is equal to IAD. So this is the IAD, which is Washington Dulles International Airport. So that's the IATA code. Whenever we try to add a new column, we need to make sure that from this data set, we can select the code and get the city name as well as any other information if you would want to add into our existing data frame. Now we can go ahead and remove all these aggregations and groupings. We are back to our original. Now we can go ahead and try to cross-file VLookup method here. So first thing, we need to upload this airport code dataset into our GigaSheet library. So I have uploaded airport codes from my local file system to GigaSheet library. So we have this. Let's come back to here, insert, cross-file lookup, select the column. We will look into the origin. Lookup file, we can select, we are interested in airport codes. And lookup column is going to be the IATA code, international, and it has to be the value, if whatever value. So new column content, it means the value available in this column has to be the value near match. So it will look into the match. If everything is match, then we can select what value we are interested into. So we could say that we are interested into the value for the municipality, it means the city name. So we are interested into this airport codes. We could say airport name. So we can add the name as well. So municipality as well as the name, that's what we are interested, and we can apply. And as you could see that these two columns has been added, municipality as well as the name, for every row depending on whatever our airport code was. So origin was the SAT, so municipality San Antonio. So if we take this and filter it on the San Antonio equals add value San Antonio, match case like whatever condition, that is going to all the records, 10,902 records for the San Antonio municipality origin. So this is how you can perform the VLookup from another data set and merge the values. So now if you need to perform the VLookup and create the new columns similar to these two, municipality and name, in our Pandas data set, we just really need to perform these similar operations here. So one thing what we need to make sure is that we must not have any duplicated entry which will confuse our merge operation in this airport code. So we can actually take this airport code and we can say airport codes equal to airport codes dot drop duplicates and subset. We can select the column. So subset will be, the column is a IATA code, and keep first means keep the very first value available. Let's run it. Now if you look into the airport code, there are 2028 rows comparative to the initially when we had 22761 rows. So here are the full operated code, and NAN is actually not a NAN value, it's actually the airport code. So we could say that pandas dot merge. Now we need to make sure whatever data sets are. So left will be our existing data frame, right will be this new airline codes data frame. Left on means the column from the left, we need to select the origin. Right on, we need to select the IATA code. How is going to tell that how we need to select? So we need to make sure that every row from the left data set. And if we run this thing, we are not storing this result into a new data set. We are just performing this operation. And if you could see here, the original 1.93 million rows has been used. And if we look into the name, and after that, these all values has been selected from this new data set, the name as well as the elevation, all that thing. But it is possible that we can only select certain fields rather than adding all the fields. So what you could do, rather than using the same operation, but you only select certain columns. So in the airport code, you actually create a subset of your columns. So you are interested into the name. You are also interested into the, let me see, interested into the name as well as the municipality. Okay, now let's run again. And IATA code, third one we need to add. So make sure that this subset of this airport code is used. Now we make sure that airport code is there. It means that whenever the new columns will be added, the IATA code is going to match with our origin. And if we are agreeing that this merge is correct, you can take this result and you can store this whole thing back into your original data frame, or you can create a new data frame. So I would say df equals. So whatever the update is going to happen is going to be in the back to df. And now this df has 3 new columns where the addition depend whatever we were looking into is going to be matched. So one thing we can validate is by using the df, where df of origin is equal to what we have done, SAT, and that gives us 10,902 row, 10,902 rows. So it means that all the work we have done here in Pandas is correct. So we have performed variety of work in Pandas and also made sure that we can do everything in the GigaSheet without even learning something new, as long as you know what is your objective in order to use the platform like GigaSheet without knowing the commands within the Pandas. In Pandas, if you would want to save this updated data set, you could actually say that df.to.csv, and now you can provide your updated file name. So updated airline delay.csv. So this whole data frame, which is in memory, will be saved to the disk, and that has been updated into this Google Colab, this environment. So updated airline delay has been in the process to be written from the memory to the disk. Now we can do ls-la, and here is your updated file. And as you could see here, that from the original one, it is definitely big, because you can do LAH. It will tell you that this is 364 meg versus 65. But again, if you compress this file CSV back to zip, then you will get at least 3 to 4 times compression. So if you want to zip, actually you can do this bang, and then you can say zip. That will let you launch the command. So you could say you want to zip, so you could say zip, this is your file name updated, and you want to as a zip file. Sorry, it's opposite. So we need to create a new zip file based on this. So zip, create a new zip file based on given file or files. 78% compression you have got. So looking into the ls-lah, this is about 81 meg. And this file has few more new columns, and these columns are string. So definitely there will be more space taken, but you can get an idea that how you can build your new data set. And if you would want to download it from Google Colab, you can just say right click, download, and this whole 81 meg file will be downloaded from Google Colab to your local file system. Similar to that, this is your final updated data set, which you could actually, the data set is currently in memory. And if you look into here, that these new columns has been added, such as municipality as well as the name. And here you can see that each column information and their type, whether it's a text type or the numeric or a date, whatever it is. This updated data set, you could actually, if you would want to export it, you select export here. Thus the file will be exported to your local file system. And I'm no way connected to GigaSheet, so I'm not endorsing the product itself. I'm just giving you an idea about the comparison between the GigaSheet as well as the Pandas. If you would have to perform everything manually versus you can just use the GigaSheet. So this Jupyter notebook, which we have worked on today, is going to be available at my DeepWorks repo in this GigaSheet workshop folder. So let me save it there. Let's push this file. And now the worksheet is available at this GigaSheet workshop folder in DeepWorks repo, and everything what we have done is all available here for you to follow. So that's all I had for you in this video. I hope you have enjoyed the hands-on workshop type of content where I go deep and explain most of the actions I'm taking while creating this video. Thank you so much for your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much again.